Hello everyone, myself Gokula Vashni and I am from Department of Food Technology in SNS College of Technology and I'm working as an assistant professor there. So I'm taking class for the second year students and today we can learn about the mass transfer operations in food tech industry and we can see the subtopic of distillation in it. So first of all, what is distillation? Distillation is a crucial separation process and it is used across many industries, leaving difference in boiling points to isolate the components. So first of all, the penetration will cover the fundamental principles behind the distillation, including the vapor pressure and Raoult's law. So we will now explore the various types of distillation techniques such as simple fractionation and vacuum distillation, detailing the specific uses and advantages. Finally, we will showcase the real-world application in the food and beverage, pharmaceuticals and chemical industries, demonstrating the versatility of the essential techniques. So next, what is the principle of distillation? So we can see about how the distillation process works in an industry. So first of all, by separating the boiling points. So distillation is a separation technique that relies on the difference in the boiling points. When a mixture is heated, the components within the lower boiling point vaporize first, allowing to separate from the other components. So the components of the mixture are separated based on their volatility. The more volatile components vaporize more relatively at a given temperature. The vapor is then cooled and condensed to collect the purified components. This process is widely used in various industries to pure liquid, separate the mixtures and produce high quality chemicals. The efficiency of the separation depends on the difference of the boiling point between the components. So next, the other principle is the vapor liquid equilibrium. So by understanding the vapor liquid equilibrium is essential for the distillation. It describes the distribution of a chemical species between the vapor and liquid phases at an equilibrium, which is critical for pretending separation efficiency. So here the Raoult's law plays an important role. So Raoult's law provides a qualitative framework to predict and control separation. It states that the vapor pressure of a component in a mixture is proportional to its mole fraction in the liquid phase and its vapor pressure in the pure state. So derivation from the Raoult's law can occur in real mixtures, especially when the components interact strongly. This derivation can affect the separation process, requiring adjustments to the distillation parameters. So now let us see about the simple versus fractional distillation. So this is a very important thing, that is the simple distillation is a single stage process for a basic separation, while the fractional distillation is a multi-stage process ideal for complex mixtures. And simple distillation is typically used in the water purification process and essential oil extraction, while the fractional distillation is used to separate the crude oil into various fractions like gasoline, kerosene and diesel. And the simple distillation involves a single vaporization and condensation cycle, and while the fractional distillation it utilizes a fractionizing column to create a temperature gradient, allowing for a multiple vaporization and condensation cycles. Next, what are the advanced technical methods used for the distillation process? So first of all, vacuum distillation. The vacuum distillation is used to separate the heat sterile liquids by lowering the pressure. And the steam distillation, it involves the use of steam to lower the boiling points of the target components and allowing to gentle separation between the temperature. And also the azeotropic distillation is employed to separate azeotropic, which with mixture of the same components in vapor and also in the liquid phase. So what are the main equipments for the distillation? So it contains of three. So first one is a still, condenser and distillation column. So the primary vessel used for the heating a mixture to its boiling point, causing it to vaporize still and come in vapor design form, simple post stills to a more complex reflux stills. Next is a condenser, where the main process takes place. So condenser cools the vapor, covering it back into a liquid state through heat exchange, and the common types includes Liebing, Graham and Erling. And next is the distillation column. It enhances separation of the components with enclosed boiling points by providing a large surface area for a vapor liquid contact. And next, let us see about the distillation in food industry. So they were be using this for the essential oil extraction, water purification, alcohol separation, and also in the flavor concentration. Next, here is the advantage and disadvantage of the distillation process. So they are a highly purity can be gained and scalability can be occurred. So these are the negative points, and also isotope has some limitation, and there is a energy intensive. So here is the future of the distillation in the food industry. So first of all, the renewable energy. So it's a complete source of a renewable energy, where the integration of renewable energy source like solar and wind power to reduce the carbon fuel footprints. And next is the process optimization. In the process of optimizing distillation process through advanced control system and innovative design to maintain maximum efficiency and minimize the waste. Next is the green technique. So developing green distillation techniques that utilize the environmentally friendly solvents and reduce the overall environmental impact. So in the overall, distillation is a role of the food industry. It is set to evolve, and the future involves the integrating and renewable energy source, optimizing a process, and employing a green techniques. These advantages promise to enhance sustainability and efficiency in food production, ensuring high quality and environmentally responsible practices. So thank you. Let us meet in the next series.